So, a few things that we want to work on today. First of all, I would like you to take the blank sheet of paper. Does everybody have a blank white piece of paper in front of them? If you don't, Oren will get you one. What I'd like you to do is, let's see here. I would like you to divide that sheet of paper in half with your pen or pencil. Just do a line right down the middle, like that. All right? And then I want you to make 10 rows. And each row can be, 3/4 of an inch or something like that. It doesn't matter. Make 10 rows. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. It doesn't matter how you space it. I didn't space mine very well. I didn't use up all my paper. Everybody got a sheet that looks something like mine? Okay. What we're going to do is I want to practice another example of completing the square with you. And I want to kind of go through it step by step so that you can just work on your computational fluency here. So that you can kind of get all your work in the right spot. And then we're going to come up with something kind of neat here. So up in your upper left hand, I want you to start, we'll all do the same equation. It's going to be 3x squared minus 5x minus 11 equals 0. Put that on your left-hand side. So what we're going to do is step by step moving down, we're going to solve that equation. And we'll do it together so nobody gets lost, okay? Over to the right, we're going to do another equation, and that equation is going to be ax squared plus bx plus c equals 0. We're going to solve these two equations at the same time. So whatever we do to the 3x squared equation on the left, we're going to do that exact same thing to the equation on the right. Notice the equation on the left has numbers, the equation on the right has letters. Instead of 3, -5, and -11, we got A, B, and C. Okay? So here we go. Let's solve the equation on the left. We're going to do this by completing the square. So, help me out, somebody. What's a good first move?
Half the x squared.
Nope. Yeah, let's get rid of the 3 first, and then we'll go to Luke. So, what we want to do is we want to divide both sides by 3 because we want 1x squared. That 3 is in the way. So we're just going to divide by 3, divide by 3, divide by 3, divide by 3. Okay? So if you divide everything by 3, you'd have x squared minus 5 over 3x minus 11 over 3 equals 0 divided by 3, which is still 0. You guys comfortable with that? We divided both sides by 3. Now I'm going to go over to this guy. Instead of dividing both sides by 3, we're going to divide both sides by a. See the difference? So divide by a. So if I divide this first guy by a, I'm just going to have x squared left over. If I do this one, it's going to be b over a x, c over a, and 0 divided by a is still going to be 0. So far, so good? Okay. What should we do next? Next line now. Get rid of the 11/3. That number's no good. It doesn't make a perfect square for me. So let's get rid of the 11/3, and I'm going to leave a gap there because we already know we're going to add a nicer number. So if I add 11/3 to both sides, I'm actually subtracting negative 11/3. Do you guys agree? Mm-hmm. So it looks like that. So the 11/3 is on the other side. So what am I going to move to my other side on this guy? C over a. So it's going to be x squared plus b over a x equals, I need to subtract it, so it'll be negative c over a. Just moved it over, right? Okay. Now, Luke, what do you want to do?
half the x squared.
Half the coefficient of this guy, half of 5/3, and then square it. So half of negative 5/3 is negative 5/6, right? Negative 5/6. And if I have negative 5/6 times negative 5/6, that gives me 25 over 36. There, we just completed the square, right? We took half of this number right here, and we squared it. 25/36. Okay, let's go over here. We want half of this number, and we want it squared. Well, this, just so I don't mess this up, I'm going to write it down here. B over A, we want half of that number, right? Well, half of it, if I take it times half, that's B over 2A. B over 2A. And then if I take B over 2A squared, which is to do B over 2A times B over 2A, on the top I get B squared, and on the bottom I get 4A squared. A little bit of multiplication exponent practice review from high school there, right? So if I half it and square it, I get B squared plus 4A squared. So I'm going to go back up to where I was. B squared over 4A squared. We're good there? Now we know that if I was going to add that 25/36, I also need to do it to the other side, right? So I can't forget about that. So I'm going to add that 25/36 to the other side. And if I'm going to add B squared over 4A squared here, I'm going to do it over here as well. Plus B squared over 4A squared. So I added the same thing to the left and the right hand side of the equation. Okay. After I did that now, what can I do? Yeah, I can now factor my left-hand side, right? So, this guy I can do as two parentheses, and it's still going to equal this 11/3 plus 25/36. My factors are going to be x and x, and what adds up to negative 5/3 such that you multiply it and get 25/36? Well, it's always the number that we had right before we squared it, right? So it's going to be x minus 5/6, x minus 5/6. And then I'll have to clean up this fraction in a little bit. We'll add those on the next step here. Okay, what about over here? I'm going to factor it, same thing. And it's going to equal this ugly stuff over here, which I'll just recopy. So again, I have x and x. What are going to be the factors of b over a such that when I multiply them I get b squared over 4a squared? Well, it's going to be the b over 2a. Remember, we had it down here. It's whatever we had before we squared it. So I want x plus b over 2a, x plus b over 2a. I have now completed the square on both of these equations. So far, so good? Okay, let's clean up this side over here. How can I rewrite this guy? X minus 5/6. Since there's two of them, I can just square it. And we'll need to get a common denominator there, but we'll come back to that. Since there's two of these guys, I can square it. And we're also going to need to get a common denominator over here, so we'll do that on the next step here. So all I did is I changed two parentheses into one and put a square with it, right? Okay, let's clean up this fraction over here that we're adding together. I need a common denominator. My common denominator is going to be 36. So if I put a common denominator of 36, what's 11 times 12 today? 132. So it's 132. I got a common denominator, 132 over 36 plus 25 over 36. And over here I'm going to do the same thing. I'm just going to get a common denominator. This one's going to be a little bit uglier. What's my common denominator here? Yeah, it's 4a squared, right? So I got to multiply, in this guy right here, I got to multiply both top and bottom times 4a, and that'll get me my common denominator. So on the top I'll have minus 4ac, and then on the bottom is 4a squared, and then I got b squared over 4a squared. Lots of fraction practice in here. Common denominators, adding and subtracting fractions. So I got a common denominator. Now I can add these guys together. I could call this x minus 5/6 squared equals 157 over 36. And over here I got x plus b over 2a squared equals, now I got a common denominator, so I just add these together. So it's negative 4ac and b squared. I'm going to put the b squared first. So I'm going to call it b squared minus 4ac all over 4a squared. So far so good? I just added my two numerators here. B squared minus 4ac, and I put it all over 4a squared. Okay. We are now ready to solve this left-hand side. I'm going to take the square root of both sides to get rid of the square. So I go like this and like this. Left over here, a square root cancels a square. I've got x minus 5/6, and that equals plus or minus the square root of 157 over the square root of 36, which we know to be 6. So I can just write it as 6 in my denominator, right? I'm going to do the same thing to my other equation. I'm going to take the square root of both sides. Here I'm going to have x plus b over 2a, because the square root and the square cancel each other, equals plus or minus. In my numerator, I got the square root of b squared minus 4ac. And here I got the square root of 4a squared, which is 2a. You guys agree that 2a times 2a gives me 4a squared? So the square root of 4a squared is 2a? We're almost home free here. If I wanted to solve the guy on the left, I've only got one thing left to do. Move the 5/6 to the other side, and I've now solved for x, right? So x equals 5/6 plus or minus the square root of 157 over 6. I only needed 9 rows, not 10. Sorry. We're done with that left-hand equation, are we not? We have two answers. Let's solve the guy on the right. I got to get rid of this b over 2a, right? So I got to subtract it. X equals negative b over 2a plus, plus or minus, I'll recopy all this. B squared minus 4ac all over 2a. And notice we have a common denominator here. So I can combine these two guys, right? So I'm going to combine them, and I'm going to say x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. What did we just do? The quadratic formula. Did you guys recognize that? Have you ever memorized it before? Some of, yeah, Pop Goes the Weasel song, maybe you memorized it. What do we use the quadratic formula for? It's a shortcut for solving quadratic equations, right? It's a shortcut for when we run into one of these ugly guys that we can't factor and we can't do it really fast and easy. We can apply the quadratic formula and we can get the answer. So, the reason I wanted to do this side by side with completing the square is to demonstrate to you what? The quadratic formula is completing the square. That's all we did, right? The only difference is we didn't do it on an equation that had numbers, namely 3, negative 5, and negative 11. We did it on an equation that had an A, a B, and a C. But we did every step exactly the same the whole way, right? So what we can do when we are faced with some quadratic equation that we want to solve and it doesn't factor nicely and quick and easy for us is we can complete the square, which we just demonstrated on the left-hand side, or we can complete the square on A, B, and C, spit out this handy-dandy formula, and then do what? Plug numbers in. Yeah. So if I go back up to my top, which one is A, B, and C? Well, A is your first one. That's your coefficient of your x squared. So A is 3. B is your coefficient of your x. So B is negative 5. And C is your constant term. So C is negative 11. So if I take those three numbers, 3, negative 5, and negative 11, and I take them all the way down to here, let's see what happens when I plug them in. B was negative 5, so negative 5 is 5 for this guy, plus or minus. I got a square root sign here. B squared, well, B was negative 5, so negative 5 squared is 25, minus 4 times A, which was 3, times C, which was negative 11, all over 2A, which is 2 times 3. Now I just got to do some arithmetic, right? So, I'm going to jump down here where I have more room on my paper. I'm going to say 5 plus or minus the square root of 25. What's 4 times 3 times 11 today? 132? And it's going to be positive because two of them are negative, right? So 25 plus 132 all over 6. So what I've got is 5/6 plus or minus the square root of 157 over 6, which is exactly the same thing I got right here when I did it with the numbers. So my hunch is that pretty much all of you have seen this before, and you've all used it before to plug in A, B, and C. However, I also bet that some of you didn't know where that equation ever came from. You just know that it showed up in a textbook somewhere, and you knew how to plug in A, B, and C. So when you're looking at this, when I say complete the square or quadratic formula, I'm really saying the same thing, right? The quadratic formula is completing the square. Okay? So now we should have different tools in our repertoire for solving quadratic equations. We can factor it, take the square root of both sides. We can use the zero product principle. We can complete the square. We can apply the quadratic formula. If you want to memorize this, great. If you don't want to, you don't have to. It's readily available in any textbook or Google search that you can type in what's the quadratic formula and it'll tell you exactly what it is, right? So it's not something that you have to memorize if you don't want to. I want to take this exact same example and I want to look at it graphically. So go ahead and open up your grapher, your quadratic formula, or I'm sorry, your GeoGebra. And down in the input bar, let's just graph 3x squared minus 5x minus 11. And there's what the graph of it looks like. I'm going to scrunch this down a little bit. So the graph looks something like that. And when we set that equal to 0 on paper, we ended up with two solutions, right? Well, if you look at it with your eyeballs and you say, where does the graph of that equation, where does it cross the x-axis, or where does it equal 0? Well, you can see the 2 points right there and right there. And you can actually have your computer put those 2 points on there. So if you go over to your new point tool and you do an intersection, I'm going to ask myself, where does that curve intersect the x-axis? So I'm going to click on the curve, then I'm going to click on the x-axis, and notice it spits out points A and B to give you a rounded answer. Mine's currently rounding to 2 decimal places, but if I went up to options and in rounding, say I went to 4 decimal places, you can see it rounds it out a little bit further. So when we did this on paper, we found out that we were going to get 5, 6 plus or minus the square root of 157 over 6. So if I figure out what the square root of 157 is on my calculator, square root of 157, it's that ugly decimal, divided by 6, whoops, divided by 6, oh, I don't know what I did there. Square root of 157 divided by 6. I'm all over the place here. Square root of 157 divided by 6. It's that. So I want 5, 6 plus or minus that, right? So if I did 5, 6 plus that number, one of my answers should be 2.92166. So if I go back to my graph, there it is, 2.9217. See that? I got the same answers. My computer's giving me the decimal. My paper is giving me the answer in radical form. So one of my answers is 2.9217 approximately. That's when I use the plus sign. Well, when I use the negative sign, it would be, I'll punch this in again, the square root of 157 divided by 6. And this time I want to take 5, 6 minus that number. So 5, 6 minus that number is negative 1.2549. And if I go back to my computer, negative 1.255, right? So there's another tool that you can use for solving quadratic equations. I can do it on paper. I can spit out a graph, right? I can do it that way. Quadratic formula, complete the square. Comments, questions? Anybody get stuck on any of that? So what happens then? I'm just going to change this guy. What happens if my equation wasn't 3x squared minus 5x minus 11? What happens if it was, I'm going to double click on it. I'm going to change that minus sign at the end. I'm going to change it to a plus sign. What happens if that was my equation? Notice where my equation, whoa, why didn't that do that? There we go. Notice where my graph sits now. When I look at it with my eyeballs, we did this a few days ago. When I look at it with my eyeballs, I'm like, well, where does it equal 0? It doesn't equal 0. See what happened to my A and B? They're not even there anymore because it doesn't intersect. So if I were to take that example and change the minus 11 to a plus 11, and I were to go back to this, what would have happened if I would have made this a plus 11 right here? When I got all the way to the end, what kind of answer was I going to get? Go ahead. It's not undefined. Imaginary. It's going to have an I in it because I'm going to end up taking the square root of a negative number. Okay? So I want you to look at our quadratic formula, which is this guy right here. This is what we finished, and we got the quadratic formula. Just looking at this quadratic formula, regardless of which equation you're trying to solve, how can you figure out if your answer is going to be real or imaginary without even going through all the work? What can you look for? Be more specific, Luke. If I'm just looking at this, let's say I plug in my numbers, my 3, my negative 5, my 11. Sometimes I'm going to get an I, and sometimes I'm not. Sometimes it's going to be imaginary, and sometimes it's going to be real, right? Now I can tell right away which ones are going to be imaginary if I graph it. It's the ones that don't hit the x-axis. That's easy. How can I tell? What am I looking for here? A negative under the square root. That's going to, so really what I'm interested in here is if I just want to know if it's going to be real or imaginary, I don't have to do the whole darn formula. What part of the formula am I interested in? Just the part underneath the square root sign. Just that part. B squared minus 4ac. There's a name for that. Anybody know it? Not determinant. Sounds like it though. It's called the discriminant. So if b squared minus 4ac, if that ends up being, let's say, greater than 0, meaning it's a positive number, what kind of solutions am I going to get? I will get real solutions. There's no i's, there's no imaginaries, because I'd be taking the square root of a positive number. What happens, though, if b squared minus 4ac is less than 0? It's negative imaginary, because I'm going to end up taking the square root of a negative number, which is I, which is imaginary. So I'm going to get 2 imaginary. And what happens if b squared minus 4ac is exactly equal to 0? It's either greater than 0, less than 0, or it could be exactly 0. I'm only going to get one answer, because notice what's going to happen. If it's 0, I'm going to take the square root of 0, and the square root of 0 is 0. So I'm going to have a plus or minus 0. Well, adding 0 and subtracting 0 is the exact same thing. So now I'm not going to have 2 answers anymore. I'm only going to have 1. Is it going to be real or is it going to be imaginary? It's going to be real. Yep. So we'll get 1 real solution, whereas here we were going to get 2 real and 2 imaginary. So with the discriminant, if you want to read up a little bit more on that, if you go to course docs and links on Blackboard, you'll remember I've put all kinds of stuff on here. If you scroll down, I've already shown you the completing the square. That's what you guys did for today's assignment. Here's deriving the quadratic formula. It's a math is fun page. It's what we just did together on the screen. But you can look at that if you want. The discriminant, math is fun. It's another little website that'll just show you what the discriminant is and how it's applied and how you can use it. And then I've already told you that I have these videos here. So that basically ends everything I was going to show you about procedural fluency, solving quadratic equations, and whatnot. So what I'm going to hand you here is a worksheet that I want you to have done for Wednesday. Okay? What this is there's several quadratic equations on here, and I'm not just interested in you solving and getting the correct answer, but the idea here is to use a little analysis so that you can determine what the best solving procedure is. Not sure if I made one for you or not. And then you need to tell me, I'm going to solve it this way because, and then justify why you are choosing the easiest or the method that's going to involve the least amount of work. Because we're all about not working any harder than we have to, right?
This is one you get.
Oh, good, because I'm one short. Thank you. Okay, here you go. Now this document is also right here. It's called Chapter 2 Analysis, but I printed it out for you. So, if you look at, I think, the first 3, it just gives you an equation. And then you need to say, well, I'm either going to factor it, I'm going to complete the square, or I'm going to use the quadratic formula. Now, what I don't want you to do is just say, I'm just going to complete the square on all of them. Or I'm going to use the quadratic formula on all of them. I want you to really think about which way is it going to be the quickest and easiest. Typically, what's the quickest and fastest way to do this? Quadratic formula? I disagree. I think I can do it faster if it's what? If it's factorable. Because if it is factorable, I can just set up 2 parentheses, set them equal to 0, and that's even easier than, then I don't have to mess with all the whole quadratic formula, right? So that's one thing I'd look at is, can I factor it? But if you sit and stare at it for longer than 20 seconds and you can't factor it, I would say, the heck with factoring, I'm going to try something different because I don't want to work any harder than I have to, right? Then it'd be like, well, should I complete the square? Or is completing the square going to be a huge pain in the butt? Remember that one that you guys did on your quiz on the website, number 3? It was like 9y squared plus 1.2y. Pain in the butt to complete the square. Why? Because it had decimals and there was a 9 in the way and it was just yuck, right? So I want you to be clever and smart about how you go about doing this. So number 1, choose a method, tell me why you're going to do it, and then solve it and show your work. Number 2, exact same thing. Choose a method. Say, I'm going to use this method because, write a little short sentence or two, and then solve it. Number 3, the exact same thing. Notice when you say, I'm choosing this method because, you can also say, I'm choosing this method because the other method is going to be a mess. You know what I mean? By default, I'm choosing this method because 2 other ways of doing it might be kind of a mess. And then finally, I want to jump to number 4. And then I'll give you some time to work on this. On number 4, notice that instead of giving you an equation and saying solve for this equation, for example, I could give you an equation that is sum ax squared plus bx plus c equals 0. And then you solve for it. And after all your solving work, you find out that x equals something and x equals something else. Right? You get 2 answers. What I'm saying now is I'm going to give you these 2 answers. And then I expect you to go backwards and see if you can tell me what the equation is. Okay? But there's one caveat with that. And you'll notice on number 4, not only am I giving you the 2 answers. Notice the 2 answers are negative 1.5 and 4. See that? Well, guess what? There are a lot of quadratic equations that have answers of negative 1.5 and 4. Think about that for a second. If I went to negative 1.5 and 4, here's negative 1, negative 2, 1, 2, 3, 4. If I said it crosses the x-axis at 4 and negative 1.5, there are many quadratics that do that. For example, it could be this quadratic right here. There's one quadratic equation that could do that. But you know what? It could be this one right here as well. Or it could be this one right here. See what I'm doing here? There's lots and lots of quadratic parabola curves that go through the 2 answers or the 2 points that I gave you. So notice what else I gave you. It also goes through the point 1.25, 30.25. So out of all those infinite number of ones that I was drawing on my screen here a second ago, only one of them is going to go through that 3rd point. Okay? So the information I'm giving you is the 2 points on the x-axis that it goes through, negative 1.5 and positive 4. It also goes through that point, and I gave you a little hint at the bottom. If you set up your factoring, x plus 1.5 and x minus 4, and then a constant k outside, if you can solve for k, you will then have the original equation, if that makes sense. So that might take a little bit of effort on your part. Okay, so I want you to get to work. You got about 10 minutes to work on this. Flag me down if you have any questions, or flag Oren down if you have any questions.
You already done, aren't you?
This will be due on Wednesday. You will notice that in the Blackboard Grade Center, there's actually a rubric right in there. This is an 18-point assignment. There's a rubric right in there, number 1. And Oren and I are going to score it on, did this, did this, did this. You get a 1, 2, 3, or 4, or whatever the rubric score is. So take a look at that rubric if you want, and then ask yourself before you turn it in, Did I do everything that the rubric is asking for? Since you guys are face-to-face students, I'll just have you actually physically hand in your paper on Wednesday. Online students, you're going to have to scan or take a picture and post yours that way, or type right into the Word document and save the Word document. Now, regardless of which solving method you choose, if I were you, I would double check my answer doing it a different method. Maybe you graph it on your computer and see if your answer on your computer matches up with what you got on paper. That's a good way to double check your answer. Yeah. If you want to stay and work for a while, obviously we have this room for another 5 minutes. If you've had enough for today and you feel like you want to take off, you can do that too. And we'll see you on Wednesday.